Thank you so much for that introduction, Michelle. My presentation today is focusing on new features in our latest CE data collection software programs that will help improve efficiency and save time. We're going to be discussing enhancements in the 3500 data collection version 4.0.1 and also new features of the SeqStudio instrument and SeqStudio data collection version 1.2.1. Here's a quick overview of what the presentation will cover. We'll discuss at a high level the new features of the latest software versions on each of the CE instruments. Unfortunately, we don't have time to go into great detail on all of the new features, but we will get to drill down into the pull-up reduction aspects, which are similar but do have slight nuances for each instrument. After reviewing the technicalities behind pull-up reduction, we'll jump into an STR kit comparison where we compared pull-up and data analysis across 5 STR kits, 2 from Applied Biosystems and 3 from other manufacturers. So we'll get started talking about the new enhancements in the 3500 data collection software version 4.0.1. After taking in a lot of customer feedback since we first released the 3500 with data collection, we were able to include some great benefits with this newest version. As it relates to improved data interpretation, we did introduce an algorithm that will reduce pull-up peaks for Applied Biosystems chemistry, and this is what's going to be covered in a lot more detail in the upcoming slides. We also optimized signal across the capillaries, and we did this in 2 ways. On a 24 cap system, we introduced a spatial optimization to account for optical variation across the 24 capillaries. And on both the 24 and 8 cap instruments, we have a recommendation for a Z offset or a higher position in the well when the capillaries go into the well for injection, and that can be performed by an engineer during a routine PM or when they first install the software by doing an auto-sampler calibration. We also introduced an algorithm for reducing off-scale data for databasing labs or those labs running robust single-source reference samples. Off-scale data recovery, what it does is it lifts the cap off the top end of the dynamic range. So right now, where your data is capped or off scale around 32,000. If you're running with off scale data recovery, that cap is lifted up to about 65,000. Also, you will see pull-up related to off scale peaks reduced. You do see a little asterisk here that mentions GeneMapper IDX version 1.6 for full functionality of the off-scale recovery feature. And that is because it's only in version 1.6 that you'll see that cap lifted up to 65,000. If you analyze these HID files in earlier versions of IDX, you will see reduced pull-up. You will see reduced pull-up also as it relates to the off-scale data, but you won't see that cap lifted up to 65K. You'll still get the off-scale indicator when peaks reach about 32,000. We also aimed to improve the user experience, and a lot of feature requests went into these enhancements. The first thing we did was we added a plate loading flexibility, where you can pause a run, bring the auto sampler forward, add a second plate, and restart the run. You also, if you have 2 plates on, could pause a run after the first plate is completed. For example, pull the auto sampler forward, take the first plate off, put a third plate on, and start the same run. And that's continual. We also added a 6-die installation standard. So on earlier versions of software, the installation standard for the HID performance check was done running Identifiler ladder. You can now have the option to run a 5-die with Identifiler ladder, same as before, or a new 6-die with Global Filer ladder performance check. We included, like I mentioned, other feature requests, things like being able to export the injection list, have a consumable log that is very easy to read to see when consumables were taken off or put on the instrument and by whom. So those are a couple other ones, but there is a full list of all the new features in the data collection user bulletin. This data collection version 4.0.1 is Win 10 supported. Talking a little bit about the SeqStudio, which is our newest CE instrument. For those that don't know, the SeqStudio is a 4-cap CE instrument. A couple ways that we're going to save time with this instrument is there is an automatic optical alignment, meaning that when the capillary is installed on the instrument, the spatial is automatic, so no need to run that manually. There's also an automatic spectral calibration adjustment, or also called in the literature auto calibration, and we're going to be talking more about that feature. But basically, you only need to run a manual spectral. You have to only set up a spectral one time for each dye set on the instrument. And after that, you don't have to run a manual spectral calibration again. You can see that this instrument is pretty small. The dimensions are there. So a nice, easy to lift, easy to move instrument to fit on a small benchtop space if that is concern in your lab. The data collection software is run right on the instrument itself. There is a touch screen that you do everything on. You set up your plates, you can monitor your run, you view results. So there's no need to have a computer attached to this instrument at all. The consumables, we have an all-in-one reagent cartridge, which you can see sitting in front of the instrument in the picture here. Everything but your cathode buffer is in this easy to handle cartridge. Your array is here, your polymer is here, and your polymer sits in a little insulator that when the cartridge is put into the instrument stays chilled, which gives the polymer a 6-month on instrument storage lifetime. Your anode buffer reservoir is in the cartridge and your polymer delivery system. The cartridge is RFID tagged, as is the cathode buffer container, which will sit on the auto sampler. There's also no more plate sandwich. Your CE plate sits right on the auto sampler, and then there's just a lid on the auto sampler that closes down over the septa that's on your plate. GMIDX version 1.6 is the IDX version that can read the .FSA files coming from the SeqStudio data collection software. So no longer .HID files on this instrument and software. And then there's also some adjunct software which is optional to use. You'll get an SAE module that you can use to set up different users and different permissions within the software and on the instrument. And then there's also a SeqStudio plate manager, which can be used to help set up your plates maps that can be imported into the instrument. I should also mention it is a single polymer type. It is a POP1 polymer for sequencing, general fragment analysis, and STR fragment analysis. So only POP1, so if you're running different applications on the SeqStudio, you don't have to worry about changing your polymer out. It is a 28 centimeter capillary array. I don't think I mentioned that either. All right, so let's get into the pull-up reduction features that are included with these data collection versions. So just to make sure we're all on the same page, we'll do a quick overview of pull-up. We'll talk about definitions and expectations first. So generally, we expect that pull-up peaks are going to be within the range of 1 to 3% of the parent peaks that they fall underneath. With off-scale data, we do know that these values could be slightly higher. So you may see pull-up above that 3% more often when you're talking about an off-scale sample. When we talk about pull-up, there are really two different types of pull-up. There's spectral pull-up and there's instrument-specific pull-up. Spectral pull-up occurs because when we run our manual calibration, we're using pure dyes. The matrix for deconvolution that is generated from that pure dye calibration then gets applied to our samples. Well, in our samples, our dyes are attached to DNA fragments, and that could affect the spectra differently. So the difference between the spectra from the dyes being attached to the samples and the dyes being pure dyes, that difference is what causes the error that causes spectral pull-up. In the raw data, spectral pull-up, you can see a pull-up peak that sits directly centered under the parent peak, and the same is true in the analyzed data. When we talk about instrument-specific pull-up, it's a little bit different. Instrument-specific pull-up all has to do with the way that the fluorescent molecules move across the detection window. So as the fluorescent tagged fragments move across the detection window, center in the window, and move out of the window, the spectrum shifts on the CCD. And what you end up seeing in the raw data is a sinusoidal shape underneath the parent peak. And then in the analyzed data, rather than seeing the pull-up peak centered under the parent peak, it will be shifted. If there is instrument-specific pull-up and spectral pull-up in the same dye channel at the same time, they would be additive. So you would see maybe a single pull-up peak, but the percentage might be slightly higher. So what does the pull-up reduction algorithm do on the 3500 in particular? So this is pull-up reduction on the 3500 data collection version 4.0.1. What the algorithm does is it allows the software to use sample-specific spectral data for AB dye sets. That's chemistry using G5, J6, or J6T. So rather than using a matrix for deconvolution based on the manual spectral that was run, that pure dye spectral, the algorithm uses data from the samples themselves. So it's a more accurate deconvolution for those samples. If, for some reason, there is limited data in a particular sample, so if you think about like a low-level sample where maybe there's only a few peaks, the algorithm is going to step back and say, hey, there's not enough data here for me to generate a spectral that is any better than the manual spectral that's stored here. So rather than trying to do something with limited data, just revert back to the manual calibration. So even with samples that don't have have a lower quality or less data, there still will be pull-up reduction. It will just be our traditional pull-up reduction based off of the manual spectral. But when there is good quality data available and the algorithm is able to generate a sample-specific matrix, it will. All pull-up reduction happens prior to the creation of the HID files, and that includes when a sample-specific data is being used. So any raw data that you see in IDX will already have the reduction applied. Now, when we talk about pull-up reduction on the SeqStudio, it's somewhat similar and somewhat different. So there are really two levels of pull-up reduction on the SeqStudio. The first level is called auto-spectral or auto-calibration, and it is similar to what we just talked about with the 3500 pull-up reduction feature. It is going to use sample-specific spectral data, but it's going to do this for any dye set. So it doesn't just have to be an AB chemistry. Any chemistry will have the benefit of the auto-spectral. Also similar to the 3500, if there's limited sample-specific data, the algorithm will still apply some level of pull-up reduction. It's a little bit different. If a previous auto-calibration matrix has been run, so you've had at least one injection in a capillary with a particular dye set that has generated an auto-calibration, the software will revert back to that auto-calibration. If there has never been an auto-calibration in that capillary for that dye set, then the software will go back to the manual calibration that was run. The second level of pull-up reduction on the SeqStudio is called marker-to-marker correction, and this is for applied biosystem dye sets only, G5, J6, and J6T. Here, we have taken into account marker-to-marker variation as it relates to pull-up across the read region of the chemistry. And this, the software will apply an optimized correction factor for each marker in each kit. And the way that you enable marker-to-marker correction is on plate setup, you'll select the chemistry that you're running. It's also similar to the 3500 in that all pull-up reduction takes place prior to the creation of the FSA files. So any data that you view in IDX will already have pull-up reduction applied. Moving on to the STR KH comparison. So this study that we did, we had some general conditions for the study that I'll cover here. We also used the same sample types for each chemistry and across the different instruments that we ran. So all amplification done on a ProFlex PCR system. Analysis all done in GeneMapper IDX version 1.6. We also analyzed using minimum peak amplitude thresholds, which I'll discuss in the upcoming slides. Otherwise, we followed manufacturers' recommendations and parameters for each kit as it related to amplification and CE injection. You can see the kits listed in the blue table. So Global Filer and NGM Detect, Global Filer IQC and NGM Detect were the two Applied Biosystems kits. Promega Fusion 6C and Promega PowerPlex ESI 17 Fast were two kits from Promega that we ran, and the QIAGEN Investigator 24-plex QS kit was the kit from QIAGEN. So 5 kits in total. You can see the different cycles that are recommended, which is how we performed amplification, and the different DNA inputs, either half a nanogram or 1 nanogram, depending on the kit. We ran what we call NP or non-probative samples. So we picked 4 samples that could be commonly encountered by a laboratory. So the first was a swab from a cell phone, the next a cigarette butt, swab from a baseball hat, and blood on cotton. We also ran the kit positive control. We utilized one 3500 XL with data collection 4.0.1 and 2 different SeqStudio instruments with data collection version 1.2.1. So I mentioned that we used minimum thresholds for our analysis, and the way that we calculated a minimum threshold was we analyzed non-template control data for each of the kits on each instrument at 1 RFU. We went into the sample and edited out any pull-up. So that could have been spikes, pull-up from the size standard, or any other artifacts. So if there was a dye blob or any raised baseline areas, that all got edited out. Once we were left with all the non-artifactual data, we did some calculations to get to the limit of quantification. So we take the average peak height of all those peaks at 1 RFU plus 10 standard deviations, and that gets us to our LOQ. And this is the RFU value where you'd expect nearly all your noise to fall below. We took that LOQ and rounded it to the nearest 5, and that was the minimum threshold. So for each dye channel, we had a different minimum threshold. If your LOQ was 22, we would have rounded down to 20 for the minimum threshold. On the 3500 instrument, across the 5 different chemistries, the minimum thresholds ranged from 35 to 85 across the dye channels. That's omitting orange, that's omitting the size standard. On the SeqStudio, if you recall, I mentioned we ran 2 different instruments, so the range is a little wider. The range was from 25 to 140 RFU across the dye channels, across all the chemistries for the 2 different instruments. Okay, I use this term complex spectral artifacts when I start talking about the results of the study, so I just want to make sure everyone's on the same page with what I mean. So traditional pull-up, that's pull-up that I'm going to be talking about. That is pull-up that falls underneath a parent peak. It's very easy to calculate a pull-up percentage, so like the top figure that you see here. When I talk about complex spectral artifacts, these are pull-up peaks that it's more difficult to figure out maybe what the which parent peak is related to the pull-up peak, or it can be like what you see in this figure here, a bridging effect, or what some people might call a pull-down effect, where we can count it as a spectral artifact if these peaks were called, these red peaks, but I didn't calculate any sort of pull-up percentage to a parent peak here. So looking at the results on our 3500 for the pull-up assessment, Applied Biosystems kits, as a reminder, will have pull-up reduction enabled, so the use of sample-specific spectral data. The non-Applied Biosystems kits have pull-up reduction disabled, so that would just be using the traditional spectral calibration with those particular dye sets. We had a positive control and 4 non-probative samples for this analysis. So in the chart here, you see there's a left side and a right side. To the far right, you can see the count of those complex pull-up peaks. So any pull-up peak that was counted, but a percentage wasn't calculated for. And then on the left side, you can see the more traditional pull-up peaks counted, and then the percentages that were calculated. So overall, you can see if you look at the average percent of the parent peak, which is in the third column here, this is all below 3%. So for all 5 kits, the average pull-up was below 3%. You can see that in the non-Applied Biosystems kits, there was some pull-up above 3% and even some pull-up above 5% in the 2 Promega kits. And I just have a different way to look at this on the next slide, since this is a lot of numbers to look at quickly. Here, what you see across the x-axis are the 5 different kits. Across the up the y-axis, I should say, are the number of pull-up peaks. So that's traditional and complex counts of pull-up combined. The different colors in the bars themselves, the red indicates the count of complex pull-up peaks. The lightest blue is pull-up that was above 5%. The next shade of blue, pull-up below 5%, and the purple pull-up that was below 3%. So what you can see overall is that the non-Applied Biosystems kits have at least 3 times the number of pull-up related artifacts compared to Global Filer IQC and NGM Detect. I wanted to put this into a relatable way to look at if you were an analyst in a lab. So I wanted to consider time saving. So what does a 3 times reduction in the number of pull-up peaks look like to someone who's taking the time to analyze the data? So I had to start with an assumption. I said, let's say it takes about 30 seconds per pull-up edit. I figured that was fair, given that some peaks will be pretty easy to visualize as pull-up. Others, you'll have to go into the raw data, maybe do some calculations, things like that. So I averaged about 30 seconds per pull-up edit. So we can say that if an Applied Biosystems kit had 70 pull-up peaks in 5 samples, which is similar to the data that we saw in this study, a non-Applied Biosystems kit would have 3 times that, or 210 pull-up peaks in 5 samples. So that would mean that it would take someone 35 minutes to analyze the Applied Biosystems kit, with an Applied Biosystems kit, 5 samples, just the pull-up peaks, versus an hour and 45 minutes to analyze pull-up and 5 samples run with a non-Applied Biosystems kit. If you double that time, considering there has to be a secondary review, we're talking about an hour and 10 minutes to analyze an Applied Biosystems kit, 5 samples, just talking about pull-up, versus 3 hours and 30 minutes for a non-AB kit, 5 samples, just talking about pull-up. So going over to the SeqStudio instrument, and if you remember, we had 2 different instruments, so this table is even a little bit busier than the last one we looked at. As a reminder, Applied Biosystems kits will have the autospectral enabled and marker-to-marker correction. The non-AB kits will just have autospectral enabled. Again, it was a positive control in 4 non-probative samples that were analyzed. So again, on the far right, you can see those complex pull-up peak counts. And then on the left, you can see the traditional pull-up counts as well as the percentages that were calculated. Again, all kits had an average pull-up percentage of less than 3%. All of the non-AB kits in this case had pull-up greater than 3% and a few had pull-up still greater than 5%. So for those that like to look at things in a different fashion, I much prefer this fashion. Very similar, 5 kits across the x-axis, the number of total pull-up peaks across, up the y-axis. You can see broken down the complex pull-up that we saw in the non-AB kits, and then the different percentage levels in the blue and purple colors. You can see a difference between Global Filer IQC and NGM Detect as far as the number of pull-up peaks, 6 versus 21 for the 2 kits. And so when we compared the Applied Biosystems kits to the non-AB kits, I did split it out because there was that discrepancy. So for Global Filer IQC, the other kits had at least 13 times the number of pull-up related artifacts. And for NGM Detect, at least 4 times the number of pull-up related artifacts. Again, considering time saving, so how might this impact you if you're the analyst and or the reviewer? Again, I assumed 30 seconds per pull-up edit, but I did split it out based on the difference we saw with Global Filer IQC and NGM Detect. So for Global Filer IQC, if there were 3 pull-up peaks in 5 samples, the other kits would have 13 times that, or 39 pull-up peaks in those 5 samples. So this would mean a time savings from 1 minute, 1.5 minutes, to analyze the 3 pull-up peaks in Global Filer IQC versus 19.5 minutes in a non-AB kit. Doubling the time for review, you see a 33-minute savings in time. A 36-minute savings in time. For NGM Detect, which would have, let's say, 10 pull-up peaks in 5 samples, the other kit would then have 4 times that, or 40 pull-up peaks in those samples. So for initial analysis, we're looking at 5 minutes versus 20 minutes, whether you're running NGM Detect or a non-AB kit. And doubling that time for review, you're talking about a 30 minutes time savings. So in conclusion, pull-up reduction on both the 3500 and SeqStudio with the latest data collection software versions greatly reduced the number of pull-up related artifacts for the Applied Biosystems kits. On the 3500, it reduced the pull-up artifacts by at least 3 times. On the SeqStudio, depending on the kit, 4 or 13 times the number of edits, reduction in the number of edits for the Applied Biosystems kits. And just as a reminder, the SeqStudio does have that added level of pull-up reduction, the marker-to-marker correction. So taking into account the pull-up reduction and also some of the new features I talked about at the very beginning of the presentation, both the 3500 data collection version 4.0.1 and the SeqStudio with data collection version 1.2.1 can streamline data analysis, especially when used in conjunction with AB STR kits. Thank you so much for your time. That concludes my presentation, and I'm going to pass the presentation over to Robert.